All right, here we go with inequalities. Today we're talking about how to solve them. Yesterday we looked at just like the basics of when it's true, when it's false, but we're going to take it a little bit further. We're going to look at solving like one-step inequality. So like over here, when we have an expression on one side and then set it less than or greater than to a number, we're going to look at that. It's very similar to equations. But when we get through the notes, you'll see that there are some slight differences. Starting with addition and subtraction, when you add or subtract the same number from each side of an inequality, it will stay true. So let's just look at that together as it says. So looking at this first inequality, 5 is less than 9. If you needed to, you could plot like 5 is over here and 9 is over here. Do we agree that is a true statement? We do, okay? I agree that 5 is less than 9. Do we agree that 11 is greater than 6? Yes, those are both true statements, okay? So starting with any inequality, if we add or subtract to both sides, it will stay true. So it says to now let's add 3 to each side and see what happens. So if I add, like if I split it like an equation, add 3 to this side, add 3 to this side, what is that new inequality? This would be 8, 12, and we'll just bring down that inequality sign. Okay, and do we agree that this statement is still true? We do. Okay, nothing has changed. Even if the sign is flipped the other way, if I add 3 to both sides, plus 3, 14, and 9, bring down that inequality sign. Is that still true? Very good. Okay, so we can take that into solving when we have x. If we want to figure out, okay, what values of x make this whole inequality true? Again, you could sit there and list it all and blah, 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 or you can solve it sort of kind of like an equation. Again, our inequality sign is like the tipping point in our little seesaw. I want to get x by itself, so I have to think, what can I do to get rid of this? Okay, hopefully you're like, oh, I need to just take away 5, keep it balanced on both sides. This cancels out. I'm left with x. 9 minus 5 is 4. Bring down that inequality sign. Okay, now this is our what we call our solution set. This gives us all of the possible answers for x in this original inequality. So it says that x is less than 4. So can x be 4? No, but it could be 3. If I put 5 plus 3, that would give me something that's less than 9. If I had put 3.5, it's less than 9. If I put 2, negative 1. Okay, so this is our solution set because it says any number x can be any number less than 4. Okay, and so we can graph that. Of course, we put 4 and I put a number on each side, so I'm going to put 3 and 5. Again, ask yourself, can it be exactly 4? The answer is no, so we have an open circle, and then it's all numbers less. 3 is less, so it's going to be all the numbers this way. Okay, over here, we're trying to get x by itself. We're going to cut the inequality. I want to get x by itself, so I'm going to undo the subtraction of 11 by adding 11 and adding 11. Cancels that out, bring down the x. 6 plus 11 is 17. Bring down that inequality sign. Okay, so it's saying that all numbers greater than 17 are going to make this true. It could be 2,000, it could be 200. But x minus 11, as long as it's greater than 17. So if I put in 18, 18 minus 11, 18 minus 11, that's 7. So that would be greater than 6. So this is, again, our solution set. I'm going to put 16, 17, and 18. Again, 17 wouldn't work because 17 would give me 6 as an end result, and 6 isn't greater than itself. So it's an open circle, and then it's going to be all numbers greater. So it's going to go this way. All right. Okay, so go ahead, try these 3 on your own. Pause and play when you're ready to check. All right, so on number 1, we should have gotten x is greater than or equal to 3. So it's a filled in dot, and it's going towards the 4 or any numbers bigger. Number 2, you should have gotten x is less than negative 6, open circle towards the left. Remember, less is on the left. And then for 3, we have a closed dot. N is less than or equal to negative 7. So closed dot, and we want all the numbers less than. Again, you can always check your solution sets by picking a number and plugging it back into your original. That's the beauty of equations and inequalities. Okay, so those were all addition and subtraction. We're going to move on to multiplication and division. So let's see if all this stuff stays true. If we start with a true inequality, if we multiply both sides by the same thing, will that inequality stay true? Okay, so do we agree that 24 is less than 40? I agree with that. I'm not going to bother graphing these because I think y'all are just good with that. Is 4 greater than 2? Check, yes. Okay, it says let's divide each side by 4. Okay, I'm going to do the work up here in this space just because I didn't really use it. I'm going to divide both sides by 4. Again, I like to use the fraction bar because then the order of the division stays the same. That new inequality, 24 divided by 4, would give me 6. Oh, I think that's going to go here. 6, and then 40 divided by 4, that's going to give me 10. And they brought down that inequality sign. So is that still a true statement? I'd say yes. Okay, multiply. Okay, so we divided on this side. Let's multiply, just making sure everything's staying true. Staying times 2 and times 2. Okay, bringing that inequality down. 4 times 2. Ooh, let me get that out of the way. Sorry. That gives me 8. 2 times 2 gives me 4. Is 8 greater than 4? Still a true statement. Okay. It says. Let's go back with the first examples and explore what happens if we use negative numbers, okay? Starting with those same inequalities as before. But let's see what happens with negatives. We had negatives up here in addition, subtraction. We had like negatives here or subtract, you know what I mean. And we were fine up here, but let's look at multiplication. So we're going to divide each side by negative 4. So we're going to divide by negative 4. I might have to squeeze that in there, negative 4. 24 divided by negative 4, signs are different. Negative wins it, and that's going to be 6. 40 divided by 4, 40 signs are different. Negative 10 wins it. Okay, we started with 24. It was less than 40. We started with a true statement. Let's look at this one. Negative 6 is less than 10. Okay, this one I might use that inequality. So let's say, okay, well, with negatives, 0's like over here. Negative 6 would come first, and then negative 10. This one's not true. Not true. Or you can say false. I don't know. Okay? Not false. You cannot rate not false, though. I'm just going to rate false. This is false. Okay? This is not, that's not right. Negative 6 is bigger than. This is a false statement. Okay, let's look over here. 4 is greater than 2. That's true. Multiply by negative 2 times negative 2. Again, you might have to write really small. 4 times negative 2, signs are different. Negative wins it, and that gives me 8 to negative 4. Is negative 8 greater? Oh, no, this one's false again. Okay, so whenever I multiplied or divided by a negative number, it doesn't stay true. So what could we do in order to make it true? Are these statements still true? No. What could we do? Okay, what we need to do, hopefully you see, okay, we can keep the numbers the same. What we need to do is change what's in the middle. Okay, we need to flip the signs. Okay, we need to flip that sign because that inequality statement isn't true. When I had a division of a negative or multiplied by a negative, I need to flip the sign. Okay, if I flip that sign, if I just say instead of less than, I make it greater than, is that statement true? Yes, this is true. True. That's a true statement, okay? Make it greater than to less than. Oh, yep, that one's true now. Okay, so do we have true statements now? Yes, we do. Okay, so again, going back, when we just divided or multiplied by a regular number, a positive number, it was fine. But what happened is whenever we multiplied or divided by a negative, that's when we needed to flip the sign. Okay, so let's go over here. I'm going to let you practice. You're trying to get x by itself. Whatever is happening to x, undo it. Maybe I'll do like this first one with you. Again, x, what's happening with 4 and x? They're getting multiplied, so I want to divide both sides. I'm going to divide them both by 4. 4 divided by itself cancels out. I'm left with x is less than, that would give me 3. Okay, if you're unsure, again, you can always plug in a number. So something that's less than 3, let's say 2. 4 times 2, is that less than 8 or less than 12? Yes, okay. I didn't need to flip the sign, so I'm good. All right, y'all try the rest of them and just practice them out. Okay, pause and play when you're ready. Okay, that graph, open dot towards the less than, should have gotten x is greater than 24, open and to the left. Okay, on this next bit, again, this is sort of going along with this. I'm going to go ahead and just have you solve it the correct way down here, where you hopefully will notice you need to do something special. So with this, okay, if I had solved negative 4x, I would divide both sides by negative 4, negative 4. Cancels out. I'm left with, oopsie, sorry. I'm left with x. And then if I divide by negative 4, that's negative 3. And they're saying, okay, if I hadn't flipped the sign, if I picked a number that's less than negative 3, let's say negative 4. If I had plugged in negative 4 back to this original thing, negative 4 times negative 4 gives me 16, positive 16, which is not less than it. So is it true? No. Okay, so what am I going to need to do? Let's try this again, but this time we need to, that's right, flip the sign of our inequality. Okay, so dividing both sides by negative 4. We get x, we get 3, negative 3 over here. And again, we need to flip this sign to make it greater. All right, over here, x divided by negative 8. I see that x is getting divided by, to get it by itself, I need to undo the division. So we do that with multiplication. And I'm going to multiply by negative 8. Okay, splitting that over. Oops, sorry, crooked there. X. 3 times negative 8 is negative 24. And again, anytime, like if you need to write it, anytime you multiply or divide, maybe write flip off to the side so you don't miss it. Flip that inequality sign to make it the other way. Okay, x is less than negative 24. So if I put negative 25, negative 24, negative 23, it's an open circle on negative 24. Sorry, my numbers are so crunched. And everything less than. Again, if I pick like, let's say negative 32. Negative 32 over negative 8 would give me positive 4, and that is greater than 3. So that works out when I flipped that sign. Okay, graphing this over here, putting negative 4, negative 3, negative 2, open circle on negative 3, and I want all the numbers greater than. So if I had put negative 2, negative 4 times negative 2, that's negative 8 is less than, or positive 8, sorry, is less than 12. Okay, it works when you flip that sign. So all in all, the big thing that you have to remember, the only thing that's sort of different than equations is whenever you multiply or divide each side of a number by a negative number, the inequality symbol must flip. It must for it to stay true. Okay, so once you do that, let's get a few more under our belt. Okay, we have some problems back here. I'm gonna let you know there might be some fractions or decimals coming up. So y'all are KAP students, y'all are aware, okay, of how those things work. So go ahead, try these 4 problems, and then we'll sort of touch base before I let you do the partner practice. Alrighty, looking at those first 3, if you actually do 8 divided by 11 or 80 divided by 110, I simplified it to get rid of those zeros to make it 8 over 11. If you do the decimal, that's fine. It's just not a pretty one, so I just left it like that. Open circle, it's going to be somewhere in between 0 and 1, and then go that way. On this one, hopefully you remember to flip because we multiplied by negative 6 on both sides, and then hopefully you weren't tricked on number 3. Even though there's a negative, we did not actually divide or multiply by negative, okay? We did not need to flip on number 3 because we didn't actually multiply or divide by negative, just that there's a negative in there, okay? Again, if you're ever unsure if you have the right answer, pick a number from that solution set and test it out. If you're ever unsure, just check it out. When in doubt, check it out. I don't know. All right. And then lastly, I'm going to do a word problem with you. Joanna's parents give her $10 per week for lunch money. She cannot decide whether she wants to buy or pack her lunch. If a hot lunch at school costs $2, write and solve an inequality to find the maximum number of times per week Joanna can buy her lunch. Okay, so we're comparing, we're talking about how much she spends, and so we're talking about however much money she can spend, and we're going to compare that to $10. Okay, we're writing ourselves an inequality, so we're always comparing 2 things, and we're comparing it to $10. Okay, so I'm going to ask myself, how do we calculate how much she spends? It's going to be $2 per lunch, so it's going to be 2 times however many lunches. X can be like the number of lunches she's buying. Okay, now we ask ourselves, can it be exactly $10? Yeah, of course it can, but we need to be less than 10. So that is me writing my inequality. And then we need to figure out how many times she can do it. So we're going to solve for x. We're going to divide both sides by 2. X is less than or equal to 5. Okay, she can buy her lunch at most 5 times. She can buy it 4, 0, 1, all that kind of stuff, but at most 5 times. Find the maximum number. 5 lunches max per week. And that's normal too, because there's no more than 5 days in a school week. Alrighty, so what you're going to do now is do the partner practice. Maybe try it on your own and then check with your partner, and then we'll come back together and check this. So pause and play. All right, here is that key. Again, pause as you're needed. I'm just scrolling sort of quickly. Pause as you need. Okay. And then your homework is going to be this last page. Please also know that the test review, it was posted in Aware, that is due tonight at 11:59 in Aware. Please do not forget to submit. Thank you guys. Please check the key on Canvas.